All right, everyone, welcome to another episode of the TWiML AI podcast. I am your host, Sam Charrington, and today I'm joined by Ali Rodell, Senior Director of Machine Learning Engineering at Capital One. Before we get going, please take a moment to hit that subscribe button wherever you're listening to today's show. Ali, welcome to the podcast.
Thank you. Very happy to be here.
I'm super excited to jump into our conversation. We'll be talking about the platform that you are building there at Capital One to support machine learning at the company. We had a great chat about old school tech just before we got started. And if we bring some of that vibe through, it'll be a lot of fun. But before we get going, I'd love to have you share, a little bit about your background, your role, how you came to work in the field, all that good stuff.
Sure. Yeah, old school tech. Yeah, I think I'm technically old for the tech for this industry. Yeah, I'm 49. So, yeah, I've been working in software engineering or in tech in general for about 26 years. Most of that in highly regulated industries of various sorts. I've actually technically done ground up data center builds way back in the day when we had that thing called data centers. But yeah, I started as a software engineer. I've worked in a bunch of different areas, including like doing a lot of data movement, like actual migration of data around the world for like these data center builds and whatnot. And just recently, or 5 years ago, joined Capital One, which was my actually entry into the machine learning space. Prior to that, I was more in the software engineering and infrastructure space. I was brought in here to help us mature our SDLC lifecycle in the machine learning space, and which is now called the MDLC, Model Development Lifecycle, I suppose, which I've helped to do since I started. Moved in a couple different places, all of which has been in the machine learning, I guess we'll call it platform space, or in the machine learning infrastructure space in general. And yeah, now I own all the model development platforms here.
Awesome. So you own model development platforms there. Let's jump right into that and talk a little bit about your really the platform journey. Were you at Capital One from the beginning of the company's involvement in machine learning? How much of that have you seen evolve?
No, I was not. It started before I got here. But it has evolved a lot. I think in general, uh, the industry. I mean, I don't need to tell you this industry is moving very quickly,
Yeah.
and evolving is even an understatement. Just like gargantuan shifts, right? When I came in, we certainly had machine learning in place. As I'm sure you've read, we've like Capital One has made some very large scale investments in getting off of antiquated infrastructure, moving into the public cloud, like really modernizing how we run everything. And because of that, we've been able to leverage the ability to redo everything over and over again, right? We can really evolve quickly because everything is elastic. So, and not to move away from the machine learning space, but you know, at the end of the day, all this stuff has to run somewhere. So, when I came in, there was certainly a fair amount of machine learning that has accelerated significantly. I actually came from working in one of our lines of business, or I came into a center area. I moved into one of our lines of business, and was building up some capabilities there. We've now consolidated all of that together, and are kind of building a consolidated offering. Like, I guess that you could say we have matured probably faster than others because of that ability to be like elastic and uh, basically do terraform destroy and kill everything and then create it again, fairly quickly. So uh, yeah, I was not here in the beginning, but it's been 5 years, so we've evolved a whole lot. since then.
Yeah. 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 It's interesting to hear you kind of ascribe to cloud the ability to counteract what I think of as two really strong kind of inertial forces. One, kind of large company with lots of existing legacy systems, and two, highly regulated industry. And you're kind of at the nexus of both, and I guess they tend to maybe go hand in hand.
Yeah, I mean, I think you're describing why my job is hard. Um, um, but yeah, I think traditionally one thinks of a bank, one thinks of a large company, and one thinks of static, not changing. We're afraid to upgrade it. And one definitely thinks of mainframe based processes. Even if you're using distributed compute, there's obviously a mainframe there somewhere, right? Um, but that, yeah, no, that's not the case. And when you um, when you look at what we're trying to build and the speed with which we have to change things, like that, it just wouldn't work. Like you're just bolting. You would be building virtualization layers on a system that was not made to move this quickly. And by that I mean, when we're let's take an example of, like, let's say you're training a very large model, and by a large model in our case I would mean 1,000 node Spark clusters. So maybe I think that's large for me. Maybe that's not large for Google. I don't know. I've never worked at Google, but large-ish, right? Like large enough that you will break things when you run a large, like 1,000 node Spark cluster for a feature generation run. Um, you're not going to run that on like a. I mean, I guess you could run it on a VMware cluster, but like it's not really going to scale, and you're not going to be able to leverage the fact that I can turn it off and go home and not pay for it, right? So like it's not uncommon for us to run many workloads of that size at the same time. um, and there's a human there. I mean, of course, we run these on a scheduled manner, but there's a human there waiting for it to finish. So like there's a way that you can leverage infrastructure now that's par for working now, right? The ability to run things at that scale. In the past, I think that would have been a big deal. Now that's just par. That's just getting us through the door. You have to be able to do that. That's the basics. That's just the foundations, right? Now we're going to be able to build on top of that. But if you don't have those foundations, you can't, like, you don't even know what you can build.
So maybe talk us through what it is that you are trying to build. Like, what's the vision? Not really kind of the far out vision, but like, what is the product that you are trying to offer the data scientists and machine learning engineers there at Capital One?
I think our job is to make it easy. Like data science is not easy, but it shouldn't be hard to do your job, right? Like my job is, and my organization's job is to make doing data science work easy, and that means you should be able to log on. If you're, let's say you're new to the company, you log on and you see how do people do data science here? What am I supposed to do? I want to be able to show you how we do work here, right? We're in a highly regulated industry. We can't just, you don't get access to everything, right? You can't just be like, "Ooh, I want to look at this customer record." No, no, no. there's a there's a whole way that this is managed and dealt with. But like once you do have access to things, I want to make it easy. I want you to be able to come in, sit down. Oh, this is how we run distributed compute. This is how we run distributed training. This is how we do experiments. This is how we like spin up Jupyter notebooks, and this is what you can do in a notebook. This is what you should not do in a notebook. Like I want it to be very, very easy. I want it to be simple. Like we try to incentivize through ease of use versus like declaratory thou must do these things. Though we also, of course, have to have those too. But we try and just make data science work easy. Um, and that's not easy.
Yeah, absolutely. Does your team's scope span from some of the low level infrastructure that we've talked about all the way up to the data scientist developer experience, managing experiments and launching notebooks and all that?
It does, yeah. So um, I I often joke that you can't really undervalue a strong DevOps team. Like it's just not actually. I guess that's not a joke. That's just a statement of fact. You can't undervalue a strong DevOps team. Yeah. So we own design of the system, provisioning of the system, day-to-day running of the system, and that includes user support. So I've got teams that will go in and be like have solid like infrastructure experience, very solid AWS experience, very solid Kubernetes, like Docker based experience, and they start to verge into understanding those data science workloads and those machine learning workloads, but they're not the folks who are going to go in and help troubleshoot like why isn't my H2O predict function working. And then I've got the other side, which is folks who are doing like hands-on implementation of reusable capabilities that data scientists will work from and actually utilize. So it kind of runs the gambit. And those teams support each other. I'm not asking a DevOps engineer to necessarily understand the underpinnings of how machine learning training is executed, but I'm asking him to understand the profile of it and how it executes. So, for example, that 1,000 node Spark cluster I mentioned in the past, 10 minutes, um, you can kill a Kubernetes cluster very easily with large scale distributed compute. So those DevOps engineers, those platform teams need to know how to scale that.
Mm. And one thing that's interesting about the conversation we're having so far is again, kind of the conversation is kind of grounded in infrastructure, and clearly you're coming at this from like a software engineering perspective, where others come at this from a data science perspective, and they're building the same tools, but worrying a lot less about the infrastructure that's running it. I'm really curious your take on the impact that's had on what you're building, the way you think about what you're building, the user experience there.
Yeah, it's interesting. It does seem like people usually come at this from one angle or the other, right? They come into this from I have an academic background, or I'm like this new machine learning engineering background, but focused on the actual implementation of machine learning. Or, and I suppose it is less common, they come at it from a systems background or from a software engineering background. Um, yeah, I have found that when you boil all of the problems down that we run into on a regular basis, they really generally fall down to software engineering fundamentals under the hood. And really, when you really boil it down, things are still constrained by the same constraints they were 30 years ago: memory, CPU, and disk IO. I mean, we have many layers of virtualization before we actually get down to some of these. But at the end of the day, the fundamentals are still there. So now when you're going way up these layers, we're building these platforms, and uh, I'm not the only person I'm sure that encounters this, but like when you're building these platforms, you're you're trying to optimize a user experience in a very immature software stack, the machine learning ecosystem, fairly immature. So with the like immature stack that we're working with, and what I mean by that is like there's a lot of what I would refer to as lazy engineering. Um, you run into a lot of things that run it, like have to run as root. This has to run as root. Nothing has to run as root. You're just not trying to make it not run as root.
Meaning stuff that your team has created or stuff that like vendors are providing or open source
Vendors are
tools?
providing open source tools. We use a lot of open source software, as do many places who are working in the machine learning space. Um, Many things need to run as root. I don't an example. Kotib, a hyperparameter optimization tool, has to run as root. I'm sure it doesn't have to run as root. I'm sure there is a way to have it not run as root, but out of the box it does. So that means we have to do something to make it so it can't run as root, because I work in a very secure place. I don't let people run things as root, right? That is a big no, right? And I programmatically prevent that from happening, right? So just as an example, like coming at this from a systems background, we're solving these problems, same problems we solved 20 years ago with the Java ecosystem, when nothing would run and you couldn't install anything. Here we are today in the machine learning ecosystem. By the way, Java ecosystem solved it, right? Sudo apt-get install Tomcat and you're good, right? That didn't work 20 years ago. Nowadays, you can't do sudo apt-get install ML platform, right? So you have to solve all these problems.
Did Java
Um,
solve that or Linux solve that?
Linux solved that. Yeah. Yeah, you're right. I guess Maven to some extent, but you're right. Linux solved that. I mean, package management has made working in software engineering just so much more pleasant. It really used to suck.
I referenced us talking about crufty technologies and like old school experiences earlier. And part of that conversation was like the JavaScript ecosystem and package management and all that kind of stuff. I think to your earlier point, like the same fundamental computing problems recur in different domains. And so do you think we'll get to apt-get install experiment management system or ML ecosystem or
I do. I do. I mean, when you look at the problems that are associated with installing software, when that software is responsible for generating large amounts of money, those problems tend to get solved. Um, and the open source ecosystem has really changed the game as far as the scale of people trying to solve problems. So it's kind of like a ratchet. I feel like it's like a ratchet. When things get solved in the open source community, they don't tend to get unsolved again, right? So it's like click, click, click forward. Oh, we've solved this package management problem. Okay, we don't have to worry about package managers anymore. I mean, you do, but you don't really, right? Or click, click, click forward. Oh, we've solved um, I don't know, running large scale like app server type stuff, right? Like Tomcat, whatever you want to insert there. Like, great, we don't have to solve that anymore, because there's thousands of engineers that contribute little changes to these things. I think it will get solved, but it'll just open up other problems. We'll have to fix, follow on problems we'll have to fix. But
and you also characterize that as apt-get install ML ecosystem. Do you think that it it is at that scope ML ecosystem or like individual tools that people will mix and match into some broader thing? Like how much another way to ask that is how customized to your environment and specific needs is the platform that you're building, which still we haven't really talked very concretely about. We've talked about it pretty abstractly, but um how customized is it to your specific needs?
so the second one's a good question. The first one's a good question. So I think would it be at the ecosystem level or would it be at the individual component level? I don't know. Um, I don't know. I think that vendor tools will allow you to do that as a ecosystem level. I think eventually we'll probably get to an open source ability to do that. I mean, today, if you don't work in a highly regulated lockdown environment, you can install Kubeflow and it works, right? And it's pretty good. That being said, in a company that controls things, either a little bit or a lot, us being, of course, on the a lot side, nothing will run without being modified. So, I think you'll find in um, really any super lockdown place, everything will have to be modified. So from our perspective, you know, we have to touch everything. It's one of the reasons why we like open source software so much, because you can pop open the hood and see what's really happening. And you can change things, right? And in some cases we will actually modify, even the like base image stuff in some of these images so that it'll run here. Now we try to commit some of those changes, of course, back upstream, but you know we have a bit of a build process there. So I would say that we modify a lot of the infrastructure side, but we try to enable capabilities that are fairly standard on the user interface side. Like if you're using open source projects, we try not to change how they're used. Like otherwise, you're just getting too much into it, and then it makes it very hard to do upgrades. So we try to keep things fairly vanilla there. Um, and when you look at the Kubernetes ecosystem with machine learning, you just have this big wealth of open source capabilities you can use. And what we end up doing is we end up really modifying how it'll run. Um, but we try to make it so that people can apply their knowledge from elsewhere here, right? Like our data scientists, we don't want them to come in and like, I don't know what any of this is, right? We want them to come in and say, oh, I've used this before, and have a familiar interface.
Yeah. So kind of taking a step back, when you think about the platform that you're building, what are the main components and how do they fit together to create the experience you're looking to create for your users?
Sure. So when you think about our data science community, they range wildly from stats PhD, kind of sort of knows Python, to super strong, what I would even refer to as a full stack data scientist. Like they're very strong engineers. So we have to enable all of them to do each of the parts. And when you think about component wise, maybe I could focus on like the stages of a model going through the system and all the pieces we have to enable. Um, when no matter if they're like the stats PhD or the full stack data sciences person, they need to come in and they need to be able to explore. They need to be able to pull in data, right? So we've got to provide Jupyter notebooks. We need to provide the ability to do exploration locally within the constraints of being able to pull data. You're not going to pull 5 terabytes of data down to your laptop. So we need to provide Jupyter notebooks. We need to provide a, an entry point to the ability to run large scale distributed compute from those Jupyter notebooks, potentially from local desktop as well, from their IDE. Um, and then when they start to need to really dig into the data, they're going to be running large scale distributed compute generally. I mean, maybe small scale, but either way, not much is done in a single instance these days. That um, is going to have significant predictive value. So we then need to enable basically Spark and Dask capabilities to be able to be run, um, I'll say easy in an easy way, which is kind of a counter statement because nothing about distributed compute is easy. But we need to enable basically Spark and Dask workloads so that people can run those workloads. We do provide I call it like t-shirt size clusters that people can use. Small, medium, large, extra, extra, extra large, that type of thing, so that people can work with it. And then once they're ready to um, start to settle on what they really need from a feature set perspective, they need to be able to, put that somewhere securely. They need to be able to put that somewhere, um, so it can be worked with and honed in on. So we provide abstractions that we build for like streaming data to our data lake, and by mean abstractions, I mean, I want to make it easy, right? I want to make it so that they can just dump data. Basically, I don't think that's the actual method call, but it's similar. Um, and dump that data. So they're working within our ecosystem. They're working in a notebook. We provide reusable components that they can work with in each of these. There's a workflow engine in there, of course, for running like DAG based workflows. And then they've got their data, same mechanisms or same entry points. They're going to start training models, right? So there's reusable components for that. It is not as easy as just using the same configurations, of course, for every model. Everything is nuanced, so we provide customizability, but we provide base capabilities that people can work from on that. And then, of course, once they have their model trained, there's along the way, there's hyperparameter optimization they're going to run. All of this is infrastructure that needs to be spun up and worked with, ideally in a way that our data scientists aren't even aware that it's happening, other than spin up time. Then they need to, of course, package and deploy the model, and that's a whole other process that is kicked off and is very controlled. But um, that those are kind of like the building blocks, I guess. And there's a lot under the hood there. There's a maybe 30-50 different Kubernetes clusters that we're working with to enable a lot of these users. Very large scale AWS infrastructure under the hood, um, all of which ideally nobody will know about, right? With through those layers of abstraction.
And to what degree does Kubeflow provide the various functionality that you're exploring, or have you had to plug things into Kubeflow for the various user facing elements? You mentioned like training models, experiment management, pushing data to different places. Are these things that you're kind of using the primitives that Kubeflow is providing, or are you using more specialized packages in that Kubeflow environment?
So we use some capabilities in Kubeflow, like their notebook provisioner. We use the capabilities on hyperparameter optimization, so the Kotib embeddings. Um, we use a lot of the visualization capabilities for Kubeflow pipelines, and the Kubeflow pipelines Argo abstraction. Um, well, we use Argo. And yeah, our Kubeflow pipelines is basically an abstraction built on top of Argo workflow. Now there is movement, of course, to potentially uh, add other workflow engines in there, but we're using Argo. Um, and But then there are other aspects of what Kubeflow provides which we do not enable. So there are some of the experiment tracking stuff, artifact store, some other capabilities there that we would rather control, and we would rather route data to our backend systems. So we have other libraries and custom built capabilities there that are either abstracted away so you don't even need to know about it. So like I'm gathering metadata on you, and or you're on your model, like you shouldn't have to tell me what you're doing, right? I should be able to get that myself. And then there are other capabilities that come shipped with Kubeflow, but we will swap them out. So like we run our own Spark abstractions, or our own Dask abstractions, that kind of thing. And technically, you could use what Kubeflow comes with, but we want it to be a little different. We need it to be either a little easier to use, or we want it to scale better or something like that. So it's a combination.
And you've referenced scaling and distributed compute quite a bit thus far. I'd love to have you talk a little bit more about that, particularly from the perspective of the challenges that you've run into, building and managing that kind of environment.
Sure, and this is one of the harder parts of what we are enabling, um, and one of the more fun parts probably, just to fix. So, I mean, Spark and Dask are fairly standard, just generally, I think, from a running distributed compute perspective. Um, they both can kill a Kubernetes cluster. Um, 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 and I can even, and as can Argo, actually, by the way. And
And what does that
but
mean,
in
kill the Kubernetes cluster,
yeah,
right? Because you kill a node and it's supposed to pop back up,
right,
you know.
right. But if you kill the control plane, uh, nothing pops back up. So yeah, we've had situations with both. So I would say there's a couple of things that you just have to consider when running any multi-tenant platform like this. One is you're running a multi-tenant platform. There are a bunch of people working on this platform, and in this case, in a user interactive mode, in a Jupyter notebook, potentially in a different UI, but they're working. This is their job. This is where they work. So you have to be careful. You don't want to let people run very, very large scale stuff that could kill the cluster. And I'll answer what I meant, what your question about what does it mean kill the cluster, um, in just a second. So you just have to be careful. What I mean by kill a cluster is, Spark, for example, um, when you shut down a Spark cluster, the actual Spark destroy uh, hits the Kubernetes can hit the Kubernetes API server all at once. It doesn't cascade. So if you run 1,000 node Spark cluster, it's 1,000 concurrent requests against the Kubernetes API server.
So
If
it's
you
just
don't,
the message floods blowing up the control
yeah, you're
plane
DDoSing
is the
yourself,
yeah,
basically.
yeah.
Yeah. And yeah, so there are ways to make that not happen. There are ways to um, use different schedulers and whatnot. But at the end of the day, if you DDoS your API server, there's a chance you're not going to recover the cluster. There are aspects of the Kubernetes control plane that are a little fragile. On the other side, in some other cases, um, we've seen Dask, for example, um, basically crush etcd. Etcd is the key value store that Kubernetes uses on the back end. Dask has crushed it. Etcd just at I actually just discussed this the other day. I think at 800 nodes of a certain configuration, etcd fell over, and and once etcd is down, you're done. You're very, very hard to recover. So that's what I mean by kill a cluster. Like it can happen. So we segregate workloads. We have we actually uh, we dubbed this we dubbed a cluster the jet train cluster, because we let people run as fast as they wanted. We have since killed that cluster. We're coming up with a new name, but basically you segregate workloads, and you ensure that your users don't expect those things to stick around, right? We want people to push the boundaries, right? We want people to run the the level of scale they need to do their jobs. So it's my job to make sure they don't notice when something falls over. So we segregate, and we make it so that if you have to try again, it's as quick as possible. But yeah, it's challenging at scale. Like I said, before, it all comes down to those fundamental three things: CPU, memory, and disk. with so many levels of abstraction on top of those things, you don't always know which one's falling over, but something falls over. And so, it's just understanding the nature of your workloads and routing things to the right place. Like I know, I won't say, of course, the names of the models, but I know certain models that require a very large amount of compute here. And I know when they need to run very large workloads. So we route them accordingly, so they don't crush their neighbors.
Yeah. Yeah. Um, you talked about the control plane issues. Kubernetes is also, people have been trying to run stateful workloads on Kubernetes for a long time. A lot of people recommend against it as well. Like, have you run into issues with the stateful nature of machine learning workloads and the kind of inherently stateless nature of Kubernetes?
Yes, we have, and some of it is, I think, users being used to being users who are used to the way, like dumping everything to HDFS on a persistent EMR cluster in AWS, for example, versus not doing that. Yes, we have. So what we've had to balance is speed of node spin up and the ability to scale massively with the ease of dumping to like essentially persistent scratch space, or the ease of being able to work in a stateful manner. And our teams who are running very large distributed capabilities seem willing to make that trade off. So dumping snapshots to S3, which is a little slower, but allows you to recover, if there are failures. Uh, Still, it works, and yes, there are capabilities you can deploy for intra-cluster storage, MinIO being one of them. I think there are others out there as well, but we actually haven't gone with any of them yet. We haven't started using them. So yeah, I think for us it was just a trade off. But you're right. It is an interesting choice for the entire industry to settle on Kubernetes, which is an inherently stateless execution engine, when we are working with inherently stateful workloads. It is an interesting quandary.
You spoke previously about the range of user personas, let's say, that you need to support. Some folks, their approach to that is to, for those folks that prefer working in Jupyter notebooks, to like try to turn the Jupyter notebook into this executable, deployable kind of artifact. Other folks, kind of say, hey, we're going to teach all our data scientists how to use, Git and, uh, kubectl and whatever those tools are, low level tools. Like, how have you managed, those kinds of decisions, and what approach do you take there?
So I'll just say firsthand, you have to use Git. You have to use source control, no matter where you fall on that paradigm, or on that range.
And to be clear, I think for some it's less about using it or not, but about like abstracting it so that every time a notebook is checkpointed, it's automatically committing, and the user doesn't know anything about it. Are you specifically saying that your users have to use it and are manually committing stuff? That's a non-negotiable in that environment.
Yes, yes, I
Okay.
believe I am saying that. So, and the reason being, you're making me think actually. Uh, so The reason being that we need to be able to recreate everything we do, right? Like we need to be able to explain how we got from this idea to this model score. And in order to do that, we need to be able to rebuild this model from scratch. Now, you can snapshot, um, you know, uh, you can use these notebooks as first class citizens in execution, and you can, paper mill. There's some couple other uh, projects out there, yeah, and they chose to basically say, well, data scientists want to work in notebooks, great, let's treat this as a first class citizen, as a really stable, operationally executable body of work. And um, we are, I would say, we are currently thinking about that right now. We do not have anything like that in place. We do allow people to, of course, work in Jupyter notebooks, use these for experiments. We will leave them running for a fairly long period of time. I don't really like the idea of this thing being permanent, but we will let them keep them up and come back in and start working the next day. But at the end of the day, as it is today, we do not think of these things as operationally executable. Um, that may change in the future. We do ask our data scientists to use source control to do some level of local, um, you know, uh, development work. Not a ton. You can absolutely work on a single instance compute node with the Jupyter notebook and have a serialized model object at the end of your process, and have a team do something with that, quote unquote.
Okay.
That is a way you can work, but we have found that people graduate from that and need more capabilities. And when you only work in a Jupyter notebook, it is hard to enforce rigor in code that goes into like building those models. So we have we're it's a balance. It's a balance, right? I don't want to turn my data scientists into software engineers. Definitely don't want to have to do that, right? I want them to do data science work, but I also want to be able to recreate the model they're building, and I want to be able to have another data scientist come in and work on that model, and be able to, you know, git clone the code and start working. So it's a balance.
Early on, you refer, and in fact, a couple of times in this conversation, you referred back to kind of these three foundational constraints that ultimately you're trying to deal with. Compute, memory, disk. Um, can you are there um, are there kind of set of guiding principles that you apply? Like when I think about those, those are long-standing constraints, or computational constraints. You're coming from a software engineering, kind of a traditional software engineering approach. We've talked a little bit about um, how that perspective is different from folks that come at it from more the model perspective. I'm wondering, and maybe abstracting a little bit, are there software engineering principles that um, kind of guide the way you approach these problems?
It's a little bit of a joke, but I actually almost reverse the principle in this concept, in this situation. Um, a lot of people think that compute is unlimited, right? Because we work in the public cloud. Like everybody read, like, compute is infinite in the cloud. Um, so one of the things we try and do is make sure that people understand that it is not. It is very scalable, but it is not unlimited. So when you think about like software engineering fundamentals, and this is not necessarily applied to data science work, but it's more applied to the productionization of what you're building, and some of the actual building of those platforms. Um, testing is a really big part of the basics here, right? Like if even for data science work, like unit tests are not a bad idea to write for some of the logic that's being built. So testing is a really big thing that we always come back to, and building just solid uh, build processes and like standards enforcement on this stuff. Um, so really down to like the basics of the SDLC lifecycle. A lot of what I think of as my job is actually to just be a very annoying person for my engineers. Like I you know, I ask about like, okay, where are your tests? Okay, great. Okay, where like how are we focusing on our code quality? Like it never, these conversations never stop, right? And I really focus a lot on those basics, on you know microservices based like abstractions, right? Like, are we doing too much in one unit, right? Like just some of these like fundamental uh, principles, we don't really ever get away from them. We focus a lot on that, even in like developing components, for example, like for like reusable components for executing within like a machine learning, like a DAG for running machine learning model training. Like there's a discussion going on actually around how much do you put into a reusable component, because there's overhead in splitting between the components. So like thinking about that from a microservices based architecture perspective, and focusing on just those building blocks. um, that's me being annoying basically with my engineers. Like we're not focusing on the high level stuff, we're focusing on like the basics of software engineering. i'm a big I'm a big proponent of a lot of testing, automated testing in particular.
Yeah, and you referenced DevOps earlier, and some of the I guess CI/CD is not strictly a DevOps thing, but I figure like I'm imagining kind of this idea of continuous delivery, continuous integration. Does that figure strongly into the way like some of the discipline that you're trying to create there?
It does. And I think there's two angles to it. There's the building of the platform, and there's the using of the platform. So within building the platform, it is as inherent in the platform building as it is in any software project, right? I have you know, myriad conversations with my engineers and with my distinguished engineer folks who are kind of guiding things around, um, you know, how are the nightly builds going? How are we, like, are we like release candidates and like downstream testing from other systems, the usual stuff, right? And then there is an element of that in the using the platform, but it shouldn't be as much, right? At the end of the day, for model training, there isn't like, I don't really want my data scientists to have to deal with like CI/CD capabilities, but at the end of the day, they do generate something at the end of their work that is then an executable, right? So that the building of that needs to be um, repeatable. You need to be able to rebuild that model in a way that is auditable. So there is a CI/CD component there, but we automate it. So it happens, but like a data scientist shouldn't have to deal with it. But it does happen. There is a auditable build process that is run on a build server somewhere that generates the serialized model object that is actually run in production.
Okay, awesome, awesome. Where do you see this all going? Both at Capital One and a little bit more broadly, the industry. We've hinted at it a little bit, but what are the short, medium, and long term kind of directions for your team and platform at Capital One? We can start there.
Wow, short, medium, and long term. All right. So I think I think that there are a couple areas that we'll be focusing on. around building more and more reusable capabilities. So I don't really want each data science team dealing with, I don't know, we'll choose a modeling framework, XGBoost, some running of like XGBoost model training, right? Like there are capabilities there that I think that can be reusable, and we have reusable components today, but I think continuing to rebuild those out and expand those. So for us, that is the case. Um, Long term, I do expect all of this to be easier. Right? I think as an industry, this will get easier. I don't think we will be in this immaturity space forever. I think we will, of course, there's the next thing that will be immature, but if I knew what that was, I'd probably be very wealthy. Um, so, but like, I think this will get easier. I think that um, the ability to integrate better explainability capabilities into these models or into the creation of these models will allow us to accelerate um, building capabilities faster, but also like it'll make us more comfortable like using prepackaged capabilities, like prepackaged software. Like we shouldn't have to necessarily go in and hack. That's my terrible phrase for doing work, right? But we shouldn't have to like go in there and like hack a lot of this stuff. Like it should be able to be run in our environment, but it isn't. So that's where we kind of get all those very strong DevOps engineers in there and kind of getting it all working. So I do think this will get easier. How is another conversation, and I'm not sure. I'm not well. Maybe if I do know, I'm not going to tell you. I don't know. Like maybe that's my like future career. But no, I don't know how necessarily. But I imagine it will get easier.
Mhm. Awesome. Awesome. Well, Ali, thanks so much for sharing with us a bit about what you've been up to and the platform you're building. And of course, you're coming from your perspective as a software engineer.
My pleasure. Thanks for having me.